Hey guys, welcome to 12.3a normal distribution. With this lesson, we're going to be looking at what is called the normal curve, and we're going to be looking at like the percentage breakups depending on a given population, looking at the mean at the very middle, and then so many standard deviations out. So in example 1, the mean and standard deviation in a normal distribution will determine the areas below. So we're always assuming that we have a normal curve. There are different types of curves when it comes to statistics, and this is one where it's distributed evenly from the mean and then it goes out certain standard deviations. So if you look here, the mean is right here in the middle. So whatever our average is, that's what goes in the very middle point. And then we will add and subtract standard deviations. So whatever the standard deviation is, we're going to add and subtract that 3 times both ways. So we got 1, 2, 3 adding, and then 1, 2, 3 subtracting as well. So what this does is it gives us different breakdowns, and each breakdown gets smaller and smaller for the percentage because the further or the more standard deviations the data is away from the mean, the less likely it is to happen. And you'll kind of see this, it'll make a little bit more sense once we look at a more concrete example. So for example 2 here, the results from a chapter test show a normal distribution. The mean test score was 78% and the standard deviation was 6. So we want to construct a normal distribution curve. So the mean is always the most important part to start with. So 78% is right here. Now with that 78% there, this is different than the percentages that we have, like the 34%, 34%, 13.5. With those are percentages in between specific standard deviations. So another thing I want to notice, so in between a standard deviation where we add and subtract, we get, erase some of these markings here. The first number that we get is 68%. So that's in between one standard deviation adding and subtracting. So the next significant mark is 95%. So that's from 2 standard deviations above and below the mean. And then 99.7% is 3 standard deviations above and below the mean. This doesn't include everything. So what we have is actually 0.15% above 3 standard deviations and 0.15% below 3 standard deviations. So now let's fill in what we know with this. So the standard deviation is 6. So I'm going to add and subtract 6 until I get 3 of these. So when I add 6, I get 84, and then 90, and then 96. So that's 3 standard deviations adding, and then I'm going to subtract it as well. So I would get 72, 66, and 60. So pretty much all of our data should fall within that range from 60 to 96. That's that 99.7%. Anything above or below is going to be in that outlier range. So the first question says, what is the probability that a randomly selected test score is between 72 and 90? So we are going from 72 to 90. We're going to use these percentages that are up here in this data chart, where 34, 34, 13.5. So let's fill those in. So this is going to be 34, 34, 13.5. We're going to continually use these numbers so you'll get pretty familiar with them. All right, so since we're going between 72 and 90, we just want to add up all the percentages that are in between those. So it's going to be 34 plus 34 plus 13.5. And then this ends up coming out to be 81.5%. So that's a pretty strong chance that we score between 72 and 90, or that a randomly selected score that we just pick out of a certain pile of tests would be 81.5% chance of being within that range. What is the probability that a randomly selected test score is greater than 90%? So now with this part, we are only looking at, I'm going to get rid of my line here. We're only looking at scores of 90 or beyond. So with this one, I'm going to take 2.35 and add the 0.15. So this is a much smaller chance This comes out to just 2.5%. So 2.5% of tests are going to be 90% or bigger than 90%. Okay. So that's all we had to do with those. We didn't have to find a certain number of tests. We were just looking at the probability of selecting one within those ranges. Now with example 3, we have a different scenario here. The heights of 3,000 women at a particular college are normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. So let's go ahead and fill in the chart first. So it's 65 is the mean, and then we are adding and subtracting 2.5. So we're going to get 67.5, 70, 72.5, and we're going to get 62.5, 60, 57.5. And then we'll fill in the percentages just like we did before. 34, 34, 13.5, 2.35, 0.15. Okay, now let's go back up to these questions now that we have our chart figured out. So with this, the next thing that we're going to think about, we have to be careful of the wording on this problem. Part A says about what percent of college women have heights below 70 inches. So we are doing everything below 70. So it's everything within this range. Now we could add up all of those little pieces together, or we could tell ourselves, well, I know what everything that is above 70 is just 2.35 and 0.15, those two together. And then I can just subtract that from 1 or 100%, I should say. So if I do 100, thinking of this whole thing as 100%, minus 2.35 plus 0.15, I'm going to end up getting 97.5%. So 97.5% of women have heights below 70 inches. Part B says about how many college women have heights between 60 inches and 65 inches. This question is different because it's not asking for the percentage answer. It wants to know an approximate number. So the first thing we want to do is find the percentage between 60 and 65. So I'm going to change my range here. 60 is right here, 65 is right there. So I'm going to add 13.5 with 34, which comes out to be 47.5%. And then that's of our total of 3,000 women. So what we got to do then is take 0.475, because I want to convert this to a decimal, and I'm going to multiply that with 3,000. This is going to give me the total amount. And it comes out to approximately, I should change that, 1,425 women. So that 3,000, it's a little bit less than half, which would be 1,500, which we expect. So 1,425, and I would agree that seems like a reasonable answer. That's between 5 feet tall and 5'5". So now this last example here, different scenario again. So let's go ahead and fill out the chart. Number of nails given length is normally distributed with a mean length of 5 inches and a standard deviation of 0.03. So we have a much smaller standard deviation here. So I'm going to write 5, and then it's 5.03, 5.06, 5.09, 4.97, 4.94, and 4.91. And we'll fill in our percentages. So the first question says, find the number of nails in a bag of 120 that are less than 4.94 inches long. So this one we're looking for an exact number, not just the percentage. So 4.94 is right here. So we want those that are less. So if we add these two numbers together, it's going to end up being I'll write it as a percentage, sorry. 2.5%, which we're going to convert to 0.025. We want to convert that to a decimal. And then we're going to multiply that with the total, which is 120. is how many are in the bag. So that's going to end up being about 3 nails. We can pull up our handy dandy calculator here just to show you how to do this. 0.025 times 120. And we do get exactly 3 with that one. Part B, find the number of nails in a bag of 120 that were between 4.97 and 5.03. So 4.97 and 5.03 is going from here to here. So that's both of the 34s together. So if we add those, we end up getting 68%. And again, out of 120, we're going to take 0.68 times 120. This one is 81.6, but obviously we wouldn't get an exact. We would round up for this one. So we would go to 82 nails. And then the last one, find the number of nails in a bag of 120 that are over 5.03. So with this one, the easiest way to do this part is to think of what these 3 added together would be. So it's going to end up being 13.5 plus 2.35 plus 0.15, which is 16%. So then we're going to change that to 0.16 and multiply it with 120. And it comes out to be 19.2, but we're going to round that to just 19 nails. We would round down on that one. All right, and that's how you do the normal distribution.